Welcome engineers, my name is TravisIQ and you need to know IPv6 for the CCNA exam and other exams and as a network engineer. Let's do this. Join me in the void as we discuss IPv6. What is IPv6? It's a 128-bit addressing space using hexadecimal characters. What is hex? Hex is the character space represented between 0 and F. Why is it between 0 and F? Because that's 16 characters, 0 through 9 and A through F. As a result, we can use any of these 16 characters to represent 4 bits. So 0 is represented by 0, 0, 0, 0 in hexadecimal because we are converting this hexadecimal character to a binary addressing scheme for the IPv6 address space. As opposed to F, which is 1, 1, 1, 1, represented by zeros and ones. This is converting hex to binary. I'm not going to give you a full binary to hex conversion. I'm letting you know what IPv6 is and what hex looks like when we convert it from hexadecimal to binary to get us to this 128-bit binary address. It's a 128-bit address. That means that you have 340 undecillion combinations of addresses. That means that you could give out 1 billion addresses every year from here to the beginning of time, or the beginning of the Earth time, right? And you wouldn't even touch the address space. You would never run out of addresses, period. That is what IPv6 is. What they did on top of this is they said, okay, we're going to make it a little bit better. We're going to reduce the size of the header. I mean, the header is a little bit larger because of the v6 addresses, but the information contained in the header is actually reduced. And if you want any additional components that are in a traditional IPv4 header, what you can do is you can use what's known as extension headers. We're not going to get into extension headers here. This is just fundamentals, but that's some of the things that they have done when introducing IPv6. Here is a traditional IPv6 address. These are what are known as hextets. And there's 1, 2, 3, 4, 5, 6, 7, 8 hextets. So 8 times 4 times 4, which is 16. This is 4 hex characters, and each hex character has 4 bits. 8 times 16 gets you to 128 bits of address space. This is an IPv6 address. You probably do not want to be manually defining IPv6 addresses for every device in your environment. What are some traditional address types? So your first IPv6 address type, a global unicast address, GUA. And the global unicast addresses in IPv6, GUA addresses, right now, as defined by IANA, right, can only start with the binary confirmation of 0, 0, 1. What hex characters can I make starting in binary with 0, 0, 1? I can make 0, 0, 1, 0. This is a 2 in binary, or 0, 0, 1, 1. That is a 3 in binary. That means that every single global unicast address on planet Earth, or elsewhere, I suppose, out in the space stations or whatnot, only begin with 2 or 3. And those are global unicast addresses. Those are addresses that you can dole out to devices on the public internet and that they can use to communicate to other devices on the public internet. Link local addresses, LLA addresses. This is another unique type of address to IPv6. LLA addresses, link local addresses, begin with the nomenclature FE80. And link local addresses are unique to that local link. What does that mean? There's another address type that's unique to local links. It's called MAC addresses. MAC addresses, although they're layer 2 addresses, burn-in addresses, are also unique to local links. That means that they cannot pass across router interfaces and that they are only confined to a single broadcast domain. That's what link local addresses are defined for. Can you use these link local addresses? Absolutely. We oftentimes will use link local addresses for router interfaces to identify your default gateway on a broadcast domain. And then finally, we have ULA, unique local addresses. And your ULA addresses, your unique local addresses, ULA, start with FC00 and have a little bit larger range, but that's the beginning of that range. And your unique local addresses are actually more similar to private IP addresses. Private IPv4, the private IPv4 address space. the address space like the 192.168.0.0/24 address space, or the 10.0.0/8 address space. These are private addresses. What does that mean? That means that they can be used to address an entire environment. They can span multiple broadcast domains in a private addressed space, but they cannot be routed on the public internet. That's why you oftentimes see these address spaces, the 10, the 192.168, the 172, right? These addresses being utilized in large environments because they are unique to those environments, because they can't be used on the public-facing internet. So you don't have to worry about those addresses coming in, so you can use whichever addresses you want. These are ULA, LLA, and global unicast addresses. There are additional components. I talked about things like extension headers that have been added to IPv6. There are new neighbor discovery protocols, NDP, which replaces ARP. There is a new DHCP for v6. If you remember, the old DHCP proceeded via DORA, which is the 4 basically exchanged packets to receive your address in DHCP v4. The new DHCP v6 uses a process called SAR. Again, a 4-packet exchange process, but slightly different, and the nomenclature is different. It uses solicit, advertise, request, and reply. These are the fundamentals of IPv6. There are some really unique things around IPv6 addressing, right, and IPv6 subnetting. Typically, your IPv6 address has a subnet size of a 6/64. That means that the first 64 bits are used for to define the network that this host is on, and the last 64 bits, right, that gets us to 128, our host. You don't have to do this, but if you start eating into these host bits, if you start making network sizes that are, if you use network bits that are larger than 64/66/70, then what you're doing is you're actually eating into the traditional host space, and your auto configuration protocols like Slack will actually fail you. This is the fundamentals of IPv6, why we introduced it, how large the address space is, what the address types are, and what they're used for. As is always the case, engineer, break stuff, have fun. I hope you enjoyed this intro. We're going to do some more IPv6 later. Let's go!